Time to review Chapter 9 with some quadratic equations and functions. So, first of all, let's talk about solving quadratic equations. We have a few different methods, and uh, sometimes you have to choose. So, let's look at number 1 here, 36x squared minus 5 equals 0. This is all set up for the square root method. We can add 5. And we have 36x squared equals 5. Let's divide by 36 on both sides. And x squared equals 5/36. And so when we're doing the square root method here, let me make a note here. This is a square root method. When we're doing the square root method, we want to get that x squared all by itself and then square root both sides. When we square root both sides, we get x equals. Now, when you do the square root method, don't forget, you get plus or minus. And now we're going to square root, since it's a fraction, we're going to square root the top and bottom because we've got to simplify it. So we have the square root of 5 is just the square root of 5. And the square root of 36 on the bottom is 6. So we can go ahead and do the square root of the bottom. We want the bottom to be a rational number. We don't want to leave square roots on the bottom, which is good that that 36 came out to be exactly a whole number. Okay. All right, number 2. So number 2, not a lot of room to work on this handout there, so we'll just work down the side here. We've got 2x minus 6 squared minus 6 equals 0. So we're going to go ahead and we want to use the square root method here also. So we want to get this bit here all by itself so we can square root. That's our goal. Okay, so again, we want the square root method. All right, so let's get rid of that 6. Let's add 6 to both sides. And we get 2 times x minus 6 squared equals 6. Let's divide by 2 to get that 2 out of there. And we got 3. And now it's time to get rid of that square there by square rooting. Both sides. We do one side, got to do the other side. So we've got x minus 6. Guess we don't need those parentheses. We'll get rid of those things. X minus 6 equals. Now don't forget your plus or minus. This is where the plus or minus comes in because we just square rooted. So now we need to add 6 to both sides. And so x equals 6 plus or minus the square root of 3. Okay? There's that. Oh, we're going to run out of room fast here. That's okay. Okay. All right, number 3 here. Got a lot going on here. So we've got 3x times x minus 2 minus 3x times x plus 1. Well, here we probably want to go ahead and simplify this. So let's go ahead and distribute this stuff out. Okay. And we're going to get 4x squared minus 8x. Now we're going to distribute this negative 3x. So we'll get negative 3x squared minus 3x equals negative 18. Now, we have x terms and x squared, so we probably want to go towards the quadratic formula on this. So let's combine like terms. Let's combine 4x squared minus 3x squared, that's x squared. Negative 8x and negative 3x, that's negative 11x. And while we're at it, since we're going to want to either factor might work, we'll see here. Let's go ahead and add 18. Whether we factor or we use a quadratic formula here, we're going to want to get the right side or one of the sides equal to 0. So we're going to add that 18 over while we're at it. And so now we can look at this here, and I think we might be able to factor. When we factor, now we got a leading coefficient of 1. That's nice because when we got a leading coefficient of 1, we just ask ourselves what are two numbers that add to negative 11 and multiply to 18. And I think we can figure that out. I think it's 2 and 9, right? Now it's 2 and 9, but they need to add to negative 11 here. So they need to be a negative 2 and a negative 9. And then when we want to solve this, we want to set this each of them equal to 0. So if these two things multiply to make 0, either this is 0 or that's 0. So either x minus 2 is 0 or x minus 9 is 0. Solve this one, add 2 to both sides, x equals 2, or add 9 to both sides, x equals 9. Okay, two answers there. So we can get, this represents two answers that are irrational, and here's two answers, 6 plus the square root of 3 and 6 minus the square root of 3. And then here we have two answers that are integers. Moving on to number 4 here. Figure out how to copy it here. Looking for two numbers that add to 2 and multiply to 3. Well, they don't exist, so we're not going to be able to factor here, so we need to use a quadratic formula. That's our next method, quadratic formula. So we want to have that memorized. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so we have, first of all, it's got to be equal to 0 like it already is. We have the a value, which is 1. We have the b value, 2, and the c value, 3. And so we're going to substitute those things here. We've got negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And now you want to work this out carefully. I would strongly recommend you just take a moment to work out the inside. Don't just go, if you go type this whole thing into a calculator, there's a very good chance that many of us will type it in wrong. So we've got to do our 2 squared minus 40. So this is 12, and we got 4. 4 minus 12 is negative 8, all over 2. Now, this is an irrational number here. So we have, actually it's going to be an imaginary number because it's a square root of a negative number. So that negative is going to come out to be an I, and the square root of 8 is the same as, so we got the square root of 8 is the square root of 4 times the square root of 2, which is 2 square root of 2. We're going to rewrite this as 2 square root of 2. Or we kind of like to put the I, 2i. We don't like to put anything after the square root because they tend to accidentally go underneath the square root. All right, so we have this. Now, since this divides both of these, now it has to divide both. You can't just divide one. But if we can simplify here, we can divide both of these here. Or maybe it'd be better if we write it this way. This is 2 over 2 plus or minus 2 squared root of 2 over 2, and I'm going to move that I out here. And now the 2's cancel. So this is negative 1 plus or minus the square root of 2, I, or I square root of 2. Okay. So there is number 4. All right, on to number 5. So number 5 here, steal a copy of this. Here it is. Okay, let me bring it on over here. Number 5. This is not going to be a square root method because we have a 2x. So we're going to want to make it equal to 0. Now, we have 1x here. We can move this x squared here, and it'd be a negative x squared, but we would like to have a leading coefficient of 1. So let's leave that alone. Let's move the 2x over there by subtracting and subtract the 5. You have to add or subtract. You can't just move them over. To move, you got to add or subtract to both sides, okay? We can try to factor, but factoring doesn't work. So we're going to need the quadratic formula. X equals, now this is our A, this is our B, and this is our C. Now we could also use completing the square, which maybe I'll go ahead and show that you can complete the square, or you can use a quadratic formula. Let me go ahead and let's show you how easy completing a square is. When you've got a leading coefficient of 1 like this, then completing the square is actually really easy. So I'm going to go ahead and put this 5 back over here, okay? So we're completing the square. Let's complete the square. So when we're completing the square, okay, or you could use a quadratic formula. So you could use a quadratic formula, but I'm going to do it the other way, okay, because we just did a quadratic formula. So here's how we complete the square. We ask ourselves, we take this b value here. So first of all, we get in this form x squared minus bx, okay? And so we're going to take half of that squared, negative 2 divided by 2 squared. Well, that is negative 1 squared, which is plus 1. So we're going to add 1 to both sides. Got to add it to this side. And we're going to end up with 6 equals, now we have this x squared minus 2x plus 1. We need to factor that. Well, that factors into x minus 1 times x minus 1, which is x minus 1 squared. So this is where, because that's a leading coefficient of 1, and because this is even, that's what makes this really easy. Completing the square is really easy. If this wasn't even, then it gets a little trickier. If this was not 1, then completing the square is a little trickier. But you do need to be ready to complete the square. You'll likely be asked a question on that. Okay, or 2. So we square root both sides, we get plus or minus, and then we're going to add 1 to both sides. And so we end up with 1 plus or minus the square root of 6 equals x. And there is number 5. Okay. If you use a quadratic formula, you'll end up in the same place. But completing the square when it's nice like that actually will save you some possible mistakes in your arithmetic there. So, all right, 6. Okay. So here again, we can try to factor. Factor doesn't work. We could complete the square or the quadratic formula. Okay, we can complete the square because it's a leading coefficient of 1, and we've got a 4 here. So I'll go and use the quadratic formula this time. There's our a, there's our b, there's our c. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, there it is. Little pop goes the weasel version. All right. All right. So 4 plus or minus, we've got negative 4 squared. If you're going to make mistakes, this is where it's going to happen 9 times out of 10. So when people make mistakes, it's under the square root. That is a positive 16. This is 4 times 1 times 8. That is 32 all over 2. So we get 4 plus or minus, and this is the square root of negative 16. And the square root of negative 16 is going to be an imaginary number. It's going to be 4i all over 2. And we want to write this as 4 over 2 plus or minus 4 over 2i. So this 2 divides both of these. And we'd like to write that as 2 plus or minus 2i. That's the final answer. Okay. All right. And that brings us to 7 here, which again has a lot going on. So we're probably going to want to simplify that again. We'll bring that over here. Whoops. Moving everything around here. Okay, so 7. A lot going on. We just want to kind of clean it up first, get into standard form. 6x squared plus 6x, distribute the negative 2x, that's negative 18x squared. Negative 2x times 3 is negative 6x. Go ahead and combine like terms. It's going to be negative 12x squared plus 6x minus x. Oh, that's nice. That goes away. Equals 10. So now it's the square root method. So it looks like a lot going on, but since the x terms disappear, we don't need the quadratic formula or anything. Just divide by negative 12, and x squared equals negative 10 twelfths, or x squared equals Let's divide those by 2, negative 5/6. And when we square root both sides, now we're square root of negative, so we're going to have an I. So x equals, we need plus or minus because we had a square root. And we're going to have I. And let's see, we got the square root of 5 over the square root of 6. Okay? We don't want to leave it that way, though, because we don't want to leave the square root on the bottom. Well, how do we get rid of that square root? We need to rationalize the denominator by multiplying by that square root. And so we have plus or minus I. We got the square root of 30 all over 6. You can't simplify those, okay? Or we could say plus minus the square root of 36 I. Okay? So need the plus or minus because of the square root, and we need the I because we had a square root of negative there. And we don't want to leave the square root on the bottom. Okay? All right. So now let's talk completing the square here, all right? If we want to complete the square, we need this to be half of the b value. So 12 divided by 2 squared. Well, that is 6 squared, which is 36. And when we factor that, we get 6, which is half of the 12. Okay. Well, over here, we're going to take the 5, actually the negative 5, divide it by 2, and square that. When we square that, we get positive 25 fourths. And when we factor this, what goes over here? Well, the thing that goes in here when we factor is negative 5. Well, we already have the negative there, I guess. It was already in the problem. So minus, which is right there, 5 halves. See, when we square this out, we get this. And when you're doing that, if you were multiplying this out, you get twice this, which is right there. Okay. So that's how we set up completing the square, which we did up a minute ago. Okay. So you need to be ready to complete the square by finding the values there, and you need to be able to solve using completing the square. So be ready for that. All right, so now we want to, for each of these, sketch the function. We should be able to find its vertex, axis symmetry, domain range, x-intercepts, and y-intercepts. Okay, and we'll write those intercepts as ordered pairs. Okay, so we have different forms here. Okay, so we have this form is our vertex form. You need to be familiar with both of these. Okay, and then this one here is standard form. And this was in the last couple lessons that we just did. Okay, so you need to be ready to use both. Okay, so let's go ahead and start with vertex form. All right, so let's bring these on over here. So copy this. Okay, there's number 10. All right, so our vertex form. Okay, the general form is y equals a times x minus h squared plus k. And so the vertex is at h comma k. Okay, so for this graph, our vertex is at, now notice it's a negative here. So this is going to be at what? This is minus negative 2. So the vertex is at negative 2. And this k value here, that's our y value. So it's going to be 4. It has shifted. Remember we talked about shifting left 2 and up 4. Okay. So our vertex is at negative 2, 4. Now I'm going to sketch a graph here. I don't have graph paper. On the test, there'll be a pre-made form you can print out if you'd like there, or you need to do a very neat and labeled graph. I'm going to label some numbers. I got 5 and 5. Okay, so at negative 2 and positive 4. Okay, so that would be right up here. We'll label that negative 2, 4. All right, so there's our vertex. Now, what else were we asked for? Oh, we were asked for the axis of symmetry. So the axis of symmetry is an equation. It is x equals -2. The axis of symmetry is always a vertical line. It goes through the vertex. Okay. We know what else? Okay, we're looking for the x-intercept and the y-intercept, the domain and the range. Okay. So let's find our x-intercept. So our x-intercept happens when y is 0. So we can take our equation and we can set y equal to 0. 0 equals -3 x plus 2 squared plus 4. Let's solve that up. Subtract 4 from both sides. We get -4 equals -3 x plus 2 squared. Divide by -3 on both sides. We're going to get, divide by -3, we're going to get 4/3 equals x plus 2 squared. I'm going to square root both sides. Okay. And we're going to get x plus 2 equals the square root of 4. Don't forget the plus or minus here. The square root of 4 on top is 2. Square root of 3 on the bottom is the square root of 3. Okay. And we could, well, we'll leave it at that, like that for now. Subtract 2 from both sides. And so we get -2 plus or minus 2 over the square root of 3. Okay, now what is that? We're going to go to our calculator. We can type that in our calculator and get a decimal value there. We're going to do the plus and the minus version. And go into our calculator with -2 plus that fraction and -2 minus, we get some -0.854, which is somewhere over here, and -3.1. So 1, 2, 3.15. So over there. Pretty ugly there. Okay. So that's not the easy part of the vertex form. Okay, vertex form is made for the vertex. Vertex was easy. Okay, x-intercept not so easy. Okay, and it wasn't too hard, but it's just ugly in this case. All right, so we need a y-intercept. The y-intercept happens when x is 0. So notice they're opposites. So when x is 0, going up to the equation there, we have, well, we're looking for f of 0, which is -3 times 0 plus 2 squared plus 4. All right, and that's going to give us -3, and this is going to be 2 squared, which is 4. -3 times 4 is -12 plus 4, which is -8. So this gives us the point 0, -8, and that is our y-intercept. So it's going to cross at -8. Okay, so somewhere way down here on my graph, 1, 2, 3, 4, 5, 6, 7, 8, let's say there. Okay, it's going to cross about 8. Now, by the way, that also tells us we know that this is symmetrical. So this is, notice this is 2 away. So from the vertex goes at -2. So 0 and down there. So if I go 2 to the left, I'm at -4. And I'm going to have a mirror image point right about over here. Okay, so that's actually enough to get a pretty decent graph there. Now we should expect it to go down because this a value is less than 0. So that means it opens down. Okay. All right, well, I think we got our x-intercept, our y-intercept. Oh, yeah, a little bit more. Let's get our domain and our range. So we got our axis of symmetry. We got our vertex. We need all those things. Okay, so our domain, the domain is the possible x values. Well, the domain, are there any x values that we cannot put in there? No. We can put all x values in there. So the domain is -infinity to infinity. That's going to be always the case for quadratics. The range, well, notice the highest point is at 4, and then these go down forever. So the range is the y values. There's no limit on the bottom, so it goes down to negative infinity. And it does stop at 4, and 4 is included, so it needs to be a square bracket, a hard bracket. All right, found all the goods there for number 10. Now 11 and 12, these are in standard form. So these are going to act similar. But we're going to approach them a little different. Okay, so let's bring that down here. Let me take a number with it, actually. Let's grab that again. Number 11. Okay, so number 11. All right, so this now has, it's in standard form. It's ax squared plus bx plus c. So when it's in this form, first thing we want to find is the axis of symmetry. Even if you're asked for things in a different order, always start with the axis of symmetry. You don't have to go in the order that was asked in the question. The axis of symmetry is x equals negative b over 2a. You need to have that memorized. Now, a little side note, that is in the quadratic formula. Remember the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Well, the axis of symmetry is right there. That is the axis of symmetry. Okay, and then this goes left and right to find zeros. So, little hint there. If you know the quadratic formula, you know the axis of symmetry. This only works when it's in standard form like this, okay? So the axis of symmetry is x equals negative b, which is 4 in this case, all over 2a, which is a is 2. So this is negative 4 over 4, which is negative 1. So the equation for the axis of symmetry is x equals negative 1. All right? Let's start our graph somewhere. How about right here? Okay, so we're going to start our graph. And all right, there's our x-axis. And here's our y-axis. Got some straight lines this time, huh? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Remember, you always need to have at least one number labeled on your x and y axis. Don't just put marks. Okay, and again, if you can use graph paper or the pre-made stuff that I'll provide for the test, that would be even better. All right, so we know that at x equals negative 1, well, that's an x value of negative 1. That means there is our axis of symmetry. And that means somewhere on that little dotted line, all right, is the vertex. And so to find the vertex, we're going to plug in negative 1. Okay, the vertex is on the axis of symmetry. So we have x equals negative 1. So in other words, we need to find g of negative 1. Well, that's 2 times negative 1 squared. Don't forget to put that negative 1 in parentheses. That changes things. Negative 1 squared is 1, positive. 4 times negative 1 is negative 4. And so this is 2 minus 4 minus 6, which is 2 minus 4 is negative 2, and negative 2 minus 6 is negative 8. Okay, so the vertex is at negative 1, negative 8. So this is negative 1, negative 8. We need to write that as a coordinate. That is a point. So this is negative 5, 6, 7, 8. So down here abouts is our vertex, negative 1, negative 8. Okay. We need to find our zeros. So we're going to set this equal to 0. Our intercepts, that is. Well, our x-intercept is when y equals 0. Okay. There's our x-intercept. So let's y equal to 0. G of x is representing the y here, right? So that's function notation. And so we need to solve this. Notice that this one happens to all be divisible by 2. If you see something like that, if you have a common factor, go ahead and divide everything by 2. It'll make your equation simpler. That's why we call it simplifying. So we divide everything by 2. Can we factor this? Be nice if we could. I think we can. How about x plus 3 and x minus 1? Those multiply to -3 and add to 2. Okay, so now we're going to solve this equation. We're solving just like we did up above. So we want x plus 3 to be 0 and x minus 1 to be 0. That gives us -3 and 1. So this is the points, -3 comma 0 and 1 comma 0. So there's our x-intercepts. Okay, so we can mark those at 1, 0 and -1, 2, 3, -3, 0. Okay. Our y-intercept, to get our y-intercept, we want the opposite x to be equal to 0. Well, that's a little easier. So we're just looking for g of 0, which is, using our formula up there, 2 times 0 squared plus 4 times 0 minus 6. Well, these just cancel because they're both 0 times 0, so this is -6. So -6 is going to be our y-intercept. And notice that is 1 away from the axis. So if we go 1 to the left, there should be another one. Now my axis kind of curved there. I didn't draw that very well. So here's a graph, not the greatest. Okay, we do expect this to go up. Okay, it's +2, so it's going up, and it's a little steeper than normal because that leading coefficient is 2. So it opens up. All right. Let's see. This is 0, comma -6 was our x and our y-intercept. Okay. Our domain for this is all real numbers because there's nothing you can't put into this equation up here, wherever it went. There it is. Okay. You can put any x value in there. Well, what y values come out? Well, the lowest y value is down at -8, and all the other ones are up above. So the range is the y values. The range starts at -8 and goes up to infinity. Okay. All right. One more. What about number 12 here? Let's see. We've got a lot going on here. So let's kind of break this up a little bit. Okay. Number 12. Let's grab number 12. Let's bring that on over here. Okay, we're going to graph this up. Okay, we know it's going to open down. We know it's 2 times as steep. Okay, so we'll start our graph here. Actually, let's get that fancy line tool out here. Okay, let's do that again. Okay, so there's our axes. Let's number them 1, 2, 3, 4, 5. 1, 2, 2, 3, 4, 5. Now remember, you can graph this on your calculator to double check, but you still need to be able to find these and show these by hand. Okay. All right. So let's go ahead and find our axis first. You always want to find our axis. X equals -b over 2a. That's the first thing you want to find when you have a standard form. Again, this is in standard form. ax squared plus bx plus c. All right, so we have x equals -9 over 2 times -2. which is negative 9 over negative 4, which is 9/4. Now, this one's going to get a little bit ugly. All right, as far as graphing goes, did it actually ask us to graph? Let's look at those instructions. Well, we kind of need to be ready. Yeah, sketch the function. Okay, so the graph's going to not be super pretty here because 9/4, that's 2 1/4. So our axis symmetry is something like that. Okay, so I know that to find the vertex. So let's first of all let's write this down. X equals 9/4. Find the vertex. We're going to plug that in here. Okay, and so we got y equals negative 9. Nope, sorry, negative 2. That's from the equation. Reading the equation here. We're going to plug this in for x. So negative 2 times 9/4 squared plus 9 times 9/4 minus 13. Okay, well, here we go. Arithmetic time. Negative 2 times 81/16. And this is 81/4. All right. And this is going to, we can go get a decimal. Could be okay here. Oops, we don't need that squared anymore. I already did the squared. Good thing because it's getting ugly. So this is, this 2 is going to cancel with 2 of those, making that 8. So this is going to be negative 81/8. And let's get a common denominator. Double this is 162/8 minus 13. All right. Well, this is going to be positive 81/8 minus 13. Yeah, just ugly. You can go, well, we can go for a mixed number here. This is 10 1/8. All right. Okay. Why haven't I gone decimal, you say? I should just go decimal. So 10 1/8 minus 13, well, that's going to be 2 7/8 negative. All right. Anyways, if you got that decimal, I think it'd be 875, 2.875, I think that is. So that's our vertex anyways. 9/4. Don't expect anything that ugly on the test. If you do, just go get a decimal out of it. Okay. So 9/4 and negative 2 7/8. Okay. So negative 2 7/8. That's somewhere down here. Okay. 9/4, negative 2 7/8. Now, I know a lot about it here. I know it's going to open down, and I know its shape. Okay, so we could get a pretty decent graph there at this point. Okay, but let's go ahead and find our y-intercept. Y-intercept is easy because that's when x equals 0. So we're going to plug in 0. That's y equals negative 2 times 0 squared plus 9 times 0 minus 13. Well, these guys just go away, and we got negative 13. So this is the point 0, negative 13, which is way down here, 5, 6, 7, 8, 9, 10, 11, 12. Way down here, don't even really care that much about it. And there's another point that's over here. Okay, so there's our y-intercept. To find our x-intercept, we want y to be 0. So we set y equal to 0 here. And we get 0 equals negative 2x squared plus 9x minus 13. And to solve that, well, we're going to need quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, now something interesting happens here. We end up with negative 9 plus or minus. Be careful on the inside. This is 81. And this is going to be 4 times 2 is 8. That's a negative. We've got negative times a negative here. That's going to be positive. Now, I like to think of this as negative 4 times negative 2 times negative 13. which means this whole thing is going to be minus or negative. 4 times 2 is 8. 8 times 13 is 180 and 24, so it's 104. Now this is a negative number. And what that tells us is that so this is going to be negative 23. Okay, so this is imaginary. I can stop right now because that means that there is no real x-intercepts. When we have an imaginary solution to the quadratic formula, that means there's no x-intercepts, which we kind of knew. We know that because we know it's pointing down because the a value is negative, so this opens down. We know it's going down this way. It's not going to be straight. It's going to be a little rounded there. It's going to be a little rounded. Okay, and so it's never going to go up and cross the x-intercept, or the x-axis, okay? So let's finish this off with our domain. Domain is always, for a quadratic formula, negative infinity to infinity. You can put anything you want for a quadratic equation. The range, well, it goes down to negative infinity, but the y value goes up to, what is that, negative 2 7/8. All right. All right, so there's our domain and our range. I think we found all the goodies there. So again, when you have a standard form, you need to find the axis symmetry first, plug that in to find the vertex. So there's our vertex. I should label this. So we first find that axis symmetry, then we find the vertex, then you can go get the intercepts and the range. Okay, kind of in that order. The domain and range is the last. Okay. All right, and the graph you can kind of make along the way. Well, a lot going on there, but hopefully that kind of solidifies some of those things there. Okay, well, on to some other situational problems, the last couple here. So number 13 here, the number of pounds of milk per day recommended for a calf is that is X weeks old can be approximated by this function here, P of X. There we go. What is the question here is, when is the calf's milk consumption the greatest? Okay, and how much milk will consume at that time? Well, whenever we have a question about the greatest or the minimum or the maximum, so this is going to be a maximum. Remember the maximum and the minimum of a parabola. Now this is a parabola, it's a quadratic equation. We have this x squared. Okay, so it's a second degree here. So whenever we're looking for the min or the max, that is going to be at the vertex. Okay, so the maximum here is going to happen at the vertex. So we're just looking for the vertex. That's the first thing you should recognize. Well, how do we find the vertex? Well, we just did that in these problems down here. Notice these are in standard form. To find the vertex, we found the axis symmetry, first of all, negative b over 2a, and we plug that in to find the vertex. So we're going to do the same thing here. Okay, so we're going to find the axis symmetry. Let me come on over here. Okay, got a little room. 13, all right. So we want to find the axis of symmetry. And so the axis symmetry is x equals negative b over 2a. So we have negative x equals negative 1.3 over 2 times negative 0.2. Okay, or the negatives are going to cancel, 1.3 over 0.4. We'll go to our calculator, see what it has to say about that. And it looks like that is 3.25. So that is when, that is the x values. The x value, as it says, is the weeks old. Okay, so we've got, erase that there. Okay, at this many weeks, so at 3.25 weeks, Well, what is the consumption? Well, that's where we got to find P. So P of 3.25, we're going to just plug it all in. Be careful there. Yeah, and it's worthwhile writing this out. 3.25 squared plus, not a lot of room here, 1.3 times 3.25 plus 6.2. Okay, so we'll calculate that. That gives us 8.3125. Okay, and so that is number of gallons. Calf's milk consumption, the greatest. Does it give us a unit? Oh yeah, so pounds actually, not gallons. Okay, the consumption will be it will be 8.3125 pounds. Doesn't tell us what to round to. We can round to 2 decimal places, it's fine. All right. So how much does the calf consume when it's 1 week old? Well, that means X is 1. And so we're going to find P of 1. When you plug that in, you'll get 7.3 pounds. Okay, so just plug it in here, and so we get negative 0.02 plus 1.3 plus 6.2. Okay, and so we should write that out at 1 week. 7.3 pounds will be consumed. Okay. All right. And then last but not least, when will it consume 3 pounds of milk? Well, that is P. So we want P of X to be equal to 3. So we're going to, let's see, going to need a little bit of room here. Okay. So how do we do that? So this is part A. We're now looking at part C here. So we're going to have 13 equal to negative 0.2x squared plus 1.3x plus 6.2. And now how do we solve this? Well, it's going to be the quadratic formula. So we got a set equal to 0. Going to need to subtract 13 from both sides. And we'll have 0 equals negative 0.2x squared plus 1.3x. And let's see, 13 minus 6.2, it's going to be negative. That's going to be 6.8. Okay, now we're going to use the quadratic formula. X equals negative b 1.3 plus or minus square root b squared minus 4 times a, negative 0.2, times c, which is negative 6.8. Okay, all over 2a. Now something, I need to check this out. All over 2 times a, which is negative 0.2. Let's see. I'd recommend trying figuring out the discriminant first, this inside part here. You want to be careful if you type this whole thing into your TI calculator. You can run into problems if you don't type it correctly with all the parentheses. So it's a good idea to do this separately if you can. And I ran into a little problem here because this comes out to be a negative number. So I got a mistake. Let's see what my mistake is. Oh, I am, no, let's see. Okay. Oh, it's 3, not 13. Yeah, so 13, you might have caught that and said, why are you doing that? Sorry about that, because I was talking and writing at the same time. So I've got to stay focused here. Okay, so that works a lot better. That's minus 3. And so 6.2 minus 3, easy to fix here because we wrote our workout. That's going to be 3.2 positive, right? And so this will be positive 3.2. And I'll go change it in my calculator. That gives me a much better number. That'll give us 4.25. Okay, so we got negative 1.3 plus or minus the square root of 4.25 all over. Maybe I'll go ahead and multiply that, negative 0.4. And now I can calculate that whole thing easily. Make sure you put the whole top in parentheses. If you're doing this on your calculator, all right, on your TI calculator there. Now, there's plus or minus, so I'm going to type in the plus first. And I know it's not showing here because I'm doing it off to the side. So if we type in the plus, we get a negative answer. So this gives us negative 1.9. Well, that's when I did the plus. Now I'm going to go change this to a minus. And so when I change this to a minus, let's see, we get positive 8.4. Okay, typing everything else in carefully. So, well, the negative answer doesn't make sense. We're looking for how many weeks, right? How many weeks? Well, that answer doesn't make sense because we don't have negative weeks. So it's going to be 8.4. All right, so we found our answer in 8.4 weeks. Okay, the consumption will be 3 pounds. All right, that's how that works there. All right, so let's look at another one here, another application. All right, a publisher is trying to minimize average cost of cost per book. So we want to minimize, that happens at the vertex. The average cost comes from this function, okay? And so we want to find the minimum, so we want to find the vertex. The minimum happens at the vertex, okay? So the vertex is at negative b over 2a, right? And so negative b over 2a is going to be negative, because there's a negative here. There's our b value. So we're going to have the negatives will cancel out. B over 2 times a, 2 times 0.015. All right, that's 0.07 over 0.030. And if we calculate that out, 0.07 divided by 0.03, that is 2.3 repeating. All right, so that's the x value. So that's the number of books in thousands. Okay, so if we plug that into our formula and get our y value, then we'll get our answer. So the vertex is at 2.33. And then we're going to plug that number into our calculator, into our equation there, and you'll get 2592. Okay. So the question is, what is the minimum cost of books and how many books need to be purchased? So you could say when 2. Now this is in thousands, right? So we can move the decimal point 3 places. Thousands is 3 decimal places. Books are printed. The cost is $25.92. Okay, put $2 on there. $25.92. Okay. Then the question is, what would the average cost be when the publisher will print 20,000 books? Well, we're going to find out what f of 20 is. And so we plug that all in, 0.015 times 20 squared minus 0.07 times 20 plus 26. And that is $30.60. Okay. When will the publisher need, or if the publisher needs a cost of 26 bucks, how many should they print? Well, we're going to solve 26 equals 0.015 x squared minus 0.07x plus 26. Okay, well, if we subtract 26, this becomes 0 equals 0.015x squared minus 0.07x. And you can solve this by either factoring. You can factor out 0.007 or use a quadratic formula. Just use use a 0 for the c value. And for sake of time, because this is getting kind of long, I'm going to just let you do that quadratic formula. You should end up with 5,000 books. Okay, that's the idea. Okay. All right, couple more here. Wrap this up. So we have 15 and 16. Okay, Ginger's fencing a rectangular area. She's going to use her house as one side. I'm going to draw a picture here for 15. We've got her house, and she's going to build a rectangle out of this here. Okay, she's got 40 yards of fencing. Now we've got a length X, we could say, and a length Y. And she wants the maximum area. Okay, so to find the maximum area, well, we need an area equation using the setup I just drew here. That's X times Y. And we need a secondary equation. Right, and so we also have another equation. We got that total is 40 yards of fencing. So 2x plus y equals 40. And if we solve that, we get 40 minus 2x. Now we can take that, we can plug that in there. And we can say the area is x times 40 minus 2x. Okay, and if we distribute that, we've got 40x minus 2x squared. Okay, now we've got a quadratic equation. If we want to find the maximum, we can find the vertex. Well, how do we find the vertex? To find the vertex, we need to find the axis symmetry first of all. So the vertex is at the axis symmetry is negative b over 2a. And then we're going to plug that in to find the function at negative b over 2a. Okay, so we want to take this equation, maybe rewrite this as negative 2x squared plus 40x. And so negative b over 2a is going to give us negative 40 over 2 times negative 2, which is negative 40 over negative 4, which is 10. Okay, so that is our axis symmetry. That is our x-coordinate there. And that gives us an area of, let's say we've got negative 2 times 10 squared plus 40 times 10. We could also plug in the up top, doesn't really matter. Negative 200 plus 400, that equals 200. Okay, so what that means is when we have an x value of 10, so the max area is 200 square yards when the dimensions are, let's say we've got 10 by, and then we've got to figure out what y is by plugging in 10 here. So 40 minus 2 times 10 is 20. So y is 20, and those are feet. Okay? So the question is, what is the maximum area? 200 square yards. And what are the dimensions? 10 by 20. So we answered it. There it is. Okay. All right, one more. We got a triangular banner for a basketball gym hangs in the gym. It has an area of 75 square feet. What is the length of the base and the height? if the base is 2/3 of the height. All right, well, one more. Here's 16. So we've got a triangle. Doesn't really matter what the triangle is because the area formula is 1/2 base times height. Okay, by the way, you should know this area formula for a rectangle. On a test, we would probably give you something more than a rectangle, but a rectangle is pretty simple. You should know how to find the area of a rectangle, but every triangle, we'd probably give that to you. Okay, but it's 1/2 base times height. All right, so we know that the base is 2/3 the height. So base equals 2/3 of the height. So we can plug that in for the base. So we have 1/2 times 2/3 h times h. And if we clean that up, the area is, well, these twos are going to cancel, and we have 1/3 h squared. So there's our little formula. And we know that the area is 75 square feet. Okay, so we want, well, let's see, I guess that's about it. What is the length of the base and the height? So if we know the area is 75 feet, we can plug that in. 75 equals 1/3 h squared. So we can multiply both sides by 3. And that's going to be 225 equals h squared. We can square root that thing. And the square root of 225 is 15, so h is 15. And we can come up here using it. We know the base is 2/3 of 15, which is 1/3 of 15 is 5. And so that's going to be 10 feet. So the base is 10 feet and the height is 15 feet. There you have it. All right, and that's it. Okay, so hope that helps there. A lot going on there. I hope you followed all that craziness there. Uh, Big things is being able to solve equations using those different methods. We have the square root method, we got factoring, and we have the quadratic formula. And then make sure you're comfortable with working with a function in standard form and a function in vertex form. Okay, standard form and our vertex form. There we go. All right. So, all right, study hard, and we'll see you soon for that test.